What's going on, guys? Welcome back to another shader tutorial. Today we're going to be looking at something a little bit more complex. We're going to be actually using the well position to create some kind of spotlight effect on our player. So we have an object that moves, we have this property for the position of the player being updated every frame, and as you can tell, we are just lighting the pixel beneath us based on this. So let's have a look at what kind of properties we can actually use in this shader. We have a couple, so right here is the spotlight size, so we can increment that as much as we want. We have the ring size, which is just like the blending in between the two textures, so we can put that on 0 if we want, and we get this kind of sharp surrounding. But you can increase that to make this a little bit more smooth. And we can actually play with that value. We also have the tint outside of this, like what color you want this to be. It can be on the white, red, everything you want really. We're going to be playing with these values today and making a shader just like this. So, like always, I'm going to be getting rid of pretty much everything, so I call this player aura, we're going to call this spotlight today. As always, I'm going to right click, create a new shader, unlit, let's call it spotlight. I'll be opening it super quickly, and on this one, I am going to type in N3K spotlight. Okay, now we can go ahead and create ourselves a material. Call it spotlight as well, and assign it our shader. And here we go. So let's just put a random color on that, like the lava texture, whatever. Put that on top of our plane, and we are now good to go. So we need to do a couple of things. Let's actually open up the spotlight and define some properties we're going to be using. There is quite a few properties we're going to be using today. We're going to be using, first off, we need the position of the player, so characters position. I'll just give this char pos, doesn't really matter what description I put. It's going to be vector, and by default we'll put it on 0, 0, 0, 0. Oops. Just like this. I'm also going to be using another float just down here for the circle radius, so that's the size of the spotlight. We can call it spotlight size in the description. It's going to be a range in between, say, 0 and maybe 20. Of course, these values are going to depend on what kind of effect you're trying to achieve. I'll put the default on, say, 3. Now we need another float just beneath that. That's the ring size. That's what I told you about, the little transition in between the two texture. So I'll just call this ring size. It's going to be a range in between 0 and 5. And by default, it's going to be 1. So you're going to have 1 meter of blending in between the two texture. By default, of course. And finally, I'll be using the color tint. So tint is going to be the outside of the spotlight color. That's a long description. It's going to be a type of color, and we're going to assign it on default by, well, default value is going to be 0, 0, 0, which stands for black with no alpha, but we're not really rendering alpha. Actually, you know what? Let's do 0, 0, 0, 1. So in case we do render alpha at one point, we actually see it. Oh, you know what? That could actually be quite fun if we don't put alpha. Okay, never mind that. Let's not put alpha. Alright, so once this is completed, we need to declare all of these again right here, because that's where we're going to be needing them. And the first one was the character position, so that is a float for. I'll just call it, well, we have to call it the same exact name, but give it the proper type. So character position is done. Circle radius was a simple float, so I'll say float circle radius. The next one was ring size, the same thing, simple float. And finally the last one was a color tint. Did I just forget? Yeah, I forgot the T here. Color tint. Here we go. And this one is also a vector. So float full and then color tint. Alright, so we've got all of these properties right now. Now we have to be playing with both of the vertex and the fragment shader. Alright, so let's jump into some quick explanation why we're using both. Right now, when you look at the effect we had earlier, it only seems like we're modifying the pixel shader, and that's true. We're not playing with the vertex at all. We didn't bend the vertex. We didn't do anything there, but we actually needed some information that were calculated in here to do that pixel lighting properly. So that's why we need to use the vertex shader here. We need to actually know where the pixel was in the world space. So this is what we're going to be calculating in here, and then make sure that this one knows where our pixel is. As always, I'd like to get rid of the fog because I never actually like using the fog, so I'll just clean this up. You can leave it, doesn't really matter. But I just want to make this as simple as possible, even though we're talking about shaders, so it's never really going to be that simple. Alright, so as always, we get the actual screen space, that's cool. We get the UV, that's also cool. I'd like to actually have the world position of that vertex though. Like, I actually need that for to calculate the distance in between the world character position and also the world vertex position. So how do we go about doing this? We know that we create a V2F structure, which is right here. We create a V2F structure and we send it over to the fragment. So what we could do is to actually create a new field in the V2F, make sure we fill it while we're inside of the vertex shader, and then send it over to the fragment. So let's go ahead and go here, declare a float3, call it world position, and now what do we put on the other side of the semantic? And that is something that is quite weird, because you have to put something. You actually have to put something because these values are going to be bound to some certain part of the GPU, and it needs to be bound to something. Now, something that is really cool though is that the texture coordinate, there's multiple of these. So in case you actually need to just declare some field like I just did right here with the world position, you could actually use texture coordinate 1, override it, and that would actually work. So later on, if you need some kind of other value, such as, I don't know, like a float 3 normal minus world pos for some reason, you could put it on texture coordinate 2. And I think, and don't quote me on this, but I think it goes up to 7, so a total of 8, including 0. But this is actually going to be the world position of that vertex. We're overriding the texture coordinate 1 because most of the time we don't use a second set of UV on our 3D object, and since we're not even using it in the rendering process, why not override it? We need a slot to put our world position, and that's exactly what we did right here. Okay, so we have the world position declared. Right now it's bound to the second set of UV, which we don't use. Let's actually override it in the vertex shader. So we'll say world position is equal to multiply, just like we did last episode, so multiply unity object to world, and using the object vertex, so when receiving app data. And then after that, we'll have to say XYZ because we're transferring that over to a float 3, and that is a float 4. Okay, so we have the world position. Technically, if we go down here and we say, oops, I.world position, we should have a value. Now it's really hard to tell right now because we don't really have any rendering going on except just put the texture on top of this, and actually it doesn't work. What? Oh, sorry, my bad. So we have to put it inside of the actual structure you declare. So you have to say O.world position. Makes a little bit more sense now. So we're back to a working shader. We are going to go down here and start writing down our equation. Alright, so to calculate the kind of effect we had, the first thing we're going to need in terms of information is to get the distance in between the pixel we're treating right now and also the character's position. So let's go ahead and declare this. Oops. Right here, it's going to be a simple float. I'll call it dist for distance. And then you can use an operation called distance, and then you input to vector. So I.worldPos is a vector 3, and then character position is a vector 4. So to transfer this character position into a vector 3, we'll do .xyz. And this way we now have the distance in between the two pixels. However, what is character position at the moment? If we have a look in the game and we click on our shader, the character position is 0, 0, 0, 0. So that's kind of boring. Let's actually set it to our the same position as our plane at the top, just for testing purpose. The position of my plane is 0.25, so I'll do 0.25 and then 4 in Y. So I'll just input that right here. So technically, the character position, if we disregard this guy, should be right here in the center where the pivot point is. Having that done, we are now going to split this into 3 sections, because there's going to be 3 sections in the end. It's going to be like the spotlight section, which is like the full color of the texture, and then the ring section, which is going to be the blending in between the two texture, and finally the outer section, which is the color tint. So let's split this in 3. This is the player's spotlight. This is the blending section, and finally this is past both the player's spotlight and the blending section. Now we have to create some kind of if statement around that. So the first one, if we are inside of the player's spotlight, we'll do if distance is smaller than circle radius. If that's the case, then we're gonna say, well, the color, then if that's the case, we'll say color is equal to the sampled color. So let's take this over here, and let's actually replace the one up top here for something like 0. 0 is actually full black. Let's have a look here what happens. We have some syntax error that's still defined, so unexpected token float. Oh, I forgot to put my semicolon, of course. If we now have a look at this, let's reread what we just wrote. So basically, by default, the color is always black. So that's 0, 0, 0. When you just write one digit like this, it actually equals to something like that. So if we were to put like 0.5, you're going to get a gray color all over the place. Okay, so that being done, let's have a look down here. We calculate the distance, and now if the distance in between the vertex and also the character's position is smaller than circle radius, which I don't remember, what is it at? It's actually on, it's the spotlight size. So if it's smaller than 3, then we take those pixels and we light them up with the texture using the UV. If we scroll that down, you're going to see that this is how it works. Alright, so this first section is completed. Now let's move over to the second section. The second section is the blending in between, and that's going to take a little bit more effort to calculate. So let's do else if. If the distance is bigger than the circle radius and the distance is smaller than the circle radius again, plus the ring size. That means we're right in between. And to test this out, I'll actually set the color on, say, 0.5, and we'll see if we are right in between. And yeah, we are. So as you can tell, if I just play with the ring size, that's the second section of our texture, and that's what we want to be playing with. Now we have to do a blending in between the main texture and also the color tint. We've done that in the past. We've did some texture blending in the past using the color.lerp actually. So let's go ahead and start calculating this. I'll need a blend strength. So strength GTH, I know how to write, awesome. And that blend strength is actually going to equal to distance minus the circle radius. And that is going to give us, that's my Facebook by the way, sorry about that. Distance minus circle radius, and that's going to give us the strength. So basically that's going to give you the distance in, this is really annoying, be right back. Sorry about that. The blank strength is basically how far you've made it inside of the ring. So once you pass the circle radius, you're making your way outside of the ring size. That's going to tell you how long you actually traveled. So using this, we could actually calculate some kind of lerp function. So let's do color is equal to lerp. We're going to lerp in between the texture to the main texture. So basically we're just sampling the texture like normal using the i.uv, and then we're going to use the color tint for the next one because that's the color we're going for if we're outside of the ring. And then we have to use the blank strength. But since this is not 0 base and we're doing a lerp right here, we'll have to do divided by ring size. And just like this, we should have a crash. So what is here? Oh, I just put text. My bad. Having no IntelliSense is really annoying. And just like this, we were able to reproduce it. So that's the actual effect we had earlier. But I'd like to go a little bit further than that. I'd like to actually go a little bit freestyle in this. What we're going to be doing right here, I'm not using this section because I basically have the black color up here, but if you want to, Well, actually, that's not gonna work if I change my tint. Let's do color tint like this. Now this way, it's actually going to work if I change my tint. Hey, amazing. Okay, but I'd like to go freestyle a little bit and play with deforming the mesh as well. So what I felt like doing is actually, instead of having this world position right here, I'd like to have a simple float. That's going to be the distance. I'll just call it distance like this. We'll remove that comment. And now what I'll do with this is I'll calculate the distance right inside of the vertex shader by doing the same exact equation. So right here, I'll go a little bit down here, and we have the world position. That's fine. Let's actually not keep it. So I'll do a float 3. Oops, float 3 world position, and then beneath that I'll do all the distance. So I'll be like taking my distance that I put in my vert to frag structure, and then I'll say is equal to distance, just like this. Now what this is going to do is it's actually going to put the distance right away, so I don't have to calculate it in here anymore. I can only say, every time we use distance, now I can say I dot dist. But I actually done that for another reason, and I'll tell you why in a second. Now that I have the distance, let's just make sure this works. So what doesn't work? Oh, the world position, that is actually just world pos. Okay, cool. So the reason I've done that is because I like to actually use my distance in my vertex shader as well. Why not actually play around with this? So what if we said o.vertex.y plus equal, and then we'll do all the distance. You actually get some really funky effect. That does not work right now, simply because I forgot to do one of the most important things, guys. I forgot to teach you how to actually set the position every frame. Because right now, if we want to do like any movement, any changement on that mesh, we'd have to be playing with this value, and that value is not something you can actually control while the game is running. So what we'll do instead is we're going to be creating a shader property, actually a script called setShaderProperty, or call it whatever you want really. And here's the simple script. This is to update every frame. We have a public material that I call material, public string, the name of the property we're changing. In our case, it's going to be character's position, and then I just took the player transform. If that player exists, then I'll say material.setVector, because we're actually setting a vector, and using the property name, we're giving the player position. This is going to do, like every frame, this is going to go under the, where's it at, the spotlight shader, find the property you actually defined, so we set character position, and then change that value to the player's position. Let me quickly just set it up so it works. I put my script on the plane, anywhere would work to be honest, because everything is public, and then drag and drop spotlight in there. The property name is character's position, and the player is this thing. If I hit play now, here it is. So we have some kind of really weird blending effect. It looks awful to be honest, but hey, we're doing something. So I find this quite cool. We could actually be playing around it a little bit, so you could be setting some kind of if here. So if vertex dot y, if distance, so all the distance is smaller or is bigger than say 3, then you do it. Else you don't do it. So it's a little bit weird, but of course you're gonna be able to tell that it's a little bit glitchy because we don't have enough vertex. Something we're going to be playing around with later is to try and create more vertex on the fly, but it's actually quite complicated, and we'll see how it works later on. So I'll be playing with this a little bit. I'll try to get some cool result, and then I'll hit you guys up in a moment. Alright, so I basically wrote some kind of really easy deformation, and I went up with something that is a little bit cool. I like it. Of course, always depends on what kind of effect you're trying to achieve. If we have a look at this right now, we get some nice, little nice blending effect, not blending, sorry, bending effect. And it looks something like this. Of course, if you're going to be making something like this in your game, you need to make sure that it's going to fit with the rest of your meshes. Right now, I get some issues, as you can tell. If I go a little bit too far, it's going to blend through my level. But I actually like this kind of effect. I was just playing around, and I hope you guys enjoyed this. I hope you learned something, and if you did, please leave me a like on the video. I always appreciate that. We're going to be looking at a lot more shaders in the future. I like doing this. It's actually quite fun to write for the GPU. So guys, thank you so much for watching. Check out the Facebook page, the Patreon page, the Discord, and I will see you guys later.